12.2, postage stamps. The relationship between the postage rate and the weight of a letter can be defined by a piecewise function. The graph shows that 2018 postage rates for using regular service to mail a letter. All right, so if I'm looking at this graph, I can see that not only is it a piecewise function, we also call this a step function, meaning that it almost looks like you're going up a flight of stairs. So when we talk about a piecewise function here, we're saying that the function is broken up into pieces, right? These are not all one continuous line. I actually have 1, 2, 3, 4 different lines. It's a function because for every x value, there's only one y value. Now, you might say, Mr. Benak, well, right here, I actually see 2 different y values for the same x value. Well, if you remember from our inequalities unit, when you see an open circle like that, that implies that the point does not exist there. So only here where there's the black circle, that's actually where the graph is. It starts right here, but only right after when x equals 1 do I actually have this graph starting. So actually there's really only one point for this x value. So that's what those open and closed dots mean, just like inequalities. All right, so number 1, what is the price of a letter that has the following weight? 1 ounce. So if I look at my graph, I look at my x-axis is weight in ounces, and y-axis is the postage in dollars. So if I look for 1 ounce, that's an x value. So I'm going here, and I see that when x is 1, y is 0.5, so that would be equal to 0.5 of a dollar or 50 cents. 1.1 ounces, so that would be right after 1. So right here. So this is the last part of this line here where my y value is 0.5. Once I get past x equals 1, I'm now jumping up to this part, this piece of the function. So once x is equal to 1.1, it looks like, I would guess that's like 0.72, 0.71. I'm looking down at the bottom of the page here and I see 0.71. So I'm going to assume that's the exact value. Sorry, oops, I made a mistake. But if you said 0.72, 0.73, 0.70, I think those would all be valid as well. All right, 0.9 ounces. All right, well, 0.9, that's less than 1, right? A little bit less than 1. So if I go right before 1, I'm still at $0.5 or 50 cents. All right, that was a little sloppy, so I'm going to fix that. All right, number 2. A letter cost 92 cents to mail. How much did the letter weigh? So if I'm looking up here, 0.92 is probably going to be right about here, and it looks like they're talking about this line here. How much did the letter weigh? Well, there are actually several different weights that could be $0.92. We see that the lowest value here is 2, but it can't be 2. It has to be above 2, right? Because that open circle means it's exclusive. It doesn't include that point. The highest point it could be is 3. So I'm going to write down here the letter weighs more than 2 ounces and less than or equal to 3. I can also write this as an inequality. I could write 2 is less than x, which is less than or equal to 3. All right, x is between those two numbers, It can equal 3. It cannot equal 2. All right, so we're going to see a lot of these inequalities now down below. And I guess I should have used W. Well, they used W because I guess that's weight. They actually didn't define their variable, so they would have lost points on the regions if they were taking this. They're using W even though they didn't even define W, so I don't really like that. But you know what? I'm going to let it slide. All right, Kieran and Mai wrote some rules to represent the postage function, but each of them made some errors. Identify the error in each person's work and write a correct set of rules. All right, so the first thing I'm going to do is I'm going to identify what's different in their work, because if there's something different, then only one of them can be right. So the first thing I notice is that this first inequality is different on both of these. Then I also notice that these two inequalities are different for both. These two are different for both. Actually, you know what? Every single one of these is different. I could circle every single inequality here, and I could get something different. The things they do have in common are the actual numbers. So it appears as though the inequalities really are the only thing that I need to correct. So I'm not, actually, I should probably erase that because one of them is right. So I should really be only identifying who's wrong. So the first thing I'm actually going to do is I'm just going to write the rules on my own because I think that's easier than looking at these two knuckleheads because they're probably both wrong to some extent. So I'm going to make mine C of W for coal. All right. And then I'm going to make a very large bracket like they did. And you'll notice that they have 4 lines. Well, when I look at my graph, I also have 4 different lines. So that sort of makes sense. Each line is K of W equals 0.5, K of W equals 0.71, K of W equals 0.92, K of W equals 1.13. And if we remember, K of W, M of W, these are just fancy ways of saying Y. So they're saying Y equals this number, Y equals that number, Y equals that number, Y equals that number. And that makes sense. Because we know when we say Y is equal to a number, that creates a horizontal line, right? Y equals 0.5, Y equals 0.71, Y equals 0.92, and Y equals 1.13. So I'm going to keep those the same because they were accurate. Those were right. There was nothing wrong with that part of their work. All right. I'm also going to put W in the middle here for each line. There's nothing wrong with that. All right, so now let's start off with 0.5. So if I look at 0.5, I'm trying to find the domain for this part of the function, right? W is x, so that means we're talking about our domain. So if I look at where W starts, I see there's an open dot when W is 0, so that means that W is greater. It doesn't equal that point. So my first sign is going to be 0 is less than W. So I can see that initially Kieran is the one who made the error, so I'm going to circle that. When I end up, the end of my domain for this first function ends at 1. And it's a filled in circle, so that's inclusive. That means W is less than or equal to 1. So in this case, Mai was wrong. All right. And actually, I'm going to notice a pattern here that for each of these, they start off with an open circle and end with a closed circle. Start off open, end close, start off open, end close. So actually, this pattern is going to occur all the way down. Right? The beginning of the domain is not inclusive. The end is inclusive. Beginning not inclusive, end is inclusive. All right, so I'm just going to copy those numbers down. Start at x equals 1, end at x equals 2. So in this case, Kieran is wrong. Actually, all the way down here, Kieran is wrong. And all the way down here, Mai is wrong. All right, next part starts at 2, ends at 3. That's the domain for the third function. Domain for the fourth function starts at 3, ends at 3.5. All right. I believe that is all for 12.2. No, we got an Are You Ready for More in 12.2. Here is an image showing how the Postal Service specifies the different mailing rates. Notice that it uses the language weight not over parentheses ounces to describe the different rates. Explain or use a sketch to show how the graph would change if the Postal Service uses under ounces instead. So, in my understanding, when I think of the word under, that's the inequality less than. When I think of the inequality not over than, I think of less than or equal to. So how would this change how the graph would look? So this looks like it's the same graph that we had before. All right. So let's read it again. They use the language weight not over to describe the different weights. So if it's not over 1 ounce, it's 50 cents. If it's not over 2 ounces, it's 71 cents. If it's not over 3 ounces, it's 92 cents. If it's not over 3.5 ounces, it's $1.13. Okay, so that's what it actually is. If we look at our graph, right, we can see that it goes up to and including 1, right? That's what that inequality would mean. So how would it change if they changed it to just under that amount? Well, if it had to be under 1 ounces, this closed circle would change to an open circle. Because if it equaled 1 ounce, that's not under 1 ounce, so we can't include that point. If we were to now not include it at 1 ounce, that means that when something weighs 1 ounce, we would have to pay extra for it. So I would actually end up filling in the circle above. Now, if I look here, it's got to be under 2 ounces. That means I can't include this point. 2 ounces is not under 2 ounces. So that means if I'm having something that weighs 2 ounces, I have to pay a little extra for it. So I'm going to include that point up there. Same thing here. We're just following that same pattern. So all it would do is it would just change the domain. So if I'm going to make a new one, let's call this B for Banak, for the Are You Ready for More, it would look very similar. I would have the same lines. Those wouldn't change at all. I would have the same W. And I would have the same numbers as well. 0, 1, 2, 3, 1, 2, 3, 3.5. What would change now would be my inequalities. This would stay the same at the beginning because that didn't change at all here. You can't mail something that doesn't weigh anything. That's not possible, right? It has to have some weight if you're mailing a letter. However, now that 1 is changing to a less than sign strictly because it can't equal 1 ounce. It's got to be under it. So that would change to this right there. And that would actually be the case all the way down here. It would always be less than. The difference would be this part here at the beginning. Now, when I begin my cost of 0.71, I'm going to include a weight of 1 ounce. So these are going to be less than or equal to, less than or equal to, and less than or equal to. All right, that's all for 12.2.